Hi, today we're going to take a look at something that we call the binormal force, or vector. And to kind of get an image of this, imagine you're in a car and you're driving up a spiraled ramp, or you're just driving up a ramp right here. And you're in a car right here. So there's my little car. All my cars look the same. This is why I teach math and not a famous artist. So we already know from our previous lessons that when we're driving up the ramp, we have our tangent vector. That's going to be the direction we're heading. We're going this direction. At any given time, we are always tangent to that curve. We also know from yesterday that we have this normal vector, which is always pointing inward, and that's our acceleration. Remember, my distance, my position is heading, my speed is always heading, or my velocity, sorry, is always heading in the direction of the curve. But my acceleration is always pointing inwards. You might remember, t of t. This was our derivative of the position vector over its magnitude. Right? That's our unit normal. And this was the second derivative divided by its the magnitude of our second derivative, which of course gives us our unit normal vector, which if r of t is my position, this is r prime of t is my speed, r double prime of t is my acceleration, and we have acceleration perpendicular to our tangent vector. So our acceleration is always pointing inwards. What we're going to talk about today is what about our how do we find out what direction we're heading? Well, to find out that direction, we take the cross product of both of those. If I take the cross product of my tangent vector and I cross that with my normal vector, that's going to give me the direction that the car is heading. So imagine you're going on your road. You going this way is your tangent vector. There's your normal vector. Well, which way is your cross product going to go? Well, of course, from our right-hand rule, we are going, of course, up. So if the cross product is positive, we are saying we are going up the ramp. If the cross product is less than 0, well, let's see what that would happen. I can't really do it. We would be going down the ramp. I couldn't twist my arm that much. Sorry, I'm getting old. So we would be going down the ramp. And in physics, we call this is called the force normal to the path. Okay? And you might remember this. So if you have, looking at a car, going down, you have mass times gravity. You have the mass of the vehicle, or the weight of the vehicle. Going up, you have that force normal. So that force normal is kind of pushing the car up the ramp in this situation right here, the way we have it. So we're going to talk a lot today about how we can find this. Now, another way to think of a binormal vector is like how we sit on a roller coaster. If you're on a roller coaster, you want that force normal to the coaster. So if you're on a roller coaster, you always have mass and your weight going down, and you always have that force normal on there, pointing up. So let's take a look at how we find the binormal vector. So a vector orthogonal of the binormal vector is orthogonal to both the tangent vector and the normal vector. So if I draw my tangent vector, I'll just draw my tangent vector, and I draw my normal vector, we already know that these are perpendicular to each other. The vector orthogonal to both of them is what's called the binormal vector. So you can kind of imagine that going out of the page, and it's going to be perpendicular to both the tangent and the normal, probably why they call it the binormal vector. And we're going to abbreviate that B of t, or the binormal vector. Right there. to calculate this, of course, we already talked about it. If it's perpendicular to both of them, the only way we can get the binormal vector is to look at their cross product, t cross n. And we can see a couple of little examples. We're going up in a spiral right here. Like right here, we have our tangent vector, we have our normal vector, our binormal vector, of course, perpendicular to both of them. So I have my tangent vector, my normal vector, my binormal vector. And as I go around the curve, that binormal vector is always going to be pointed up. Other phrases that we tend to use in physics, sometimes we call this the rotational force, or sometimes called the torque. You might hear that like in TV shows and everything. So in order to calculate this, the equation is going to be the unit tangent. We're going to cross that with the unit normal vector, and that is our equation. However, you might recall, sometimes these are not easy to calculate. So we have another way we can do this. There is a shortcut. And that is if, and only if, the magnitude of my velocity vector is constant. If the magnitude is constant, ready? If I were to take my unit tangent, cross that with my unit normal vector. Well, if my unit tangent vector, remember this is r prime over the magnitude of r prime, I'm going to cross that with my unit normal, r double prime over the magnitude of r double prime. Well, if r prime is constant, I could rewrite this as just r prime cross r double prime over r prime cross r double prime, the magnitude. And this way is actually a lot shorter. So this is another way we can write our binormal vector, or calculate it. And we're going to see just how much easier that will be for us. So let's take a look at one example, and then we'll take a break. Given the equation, given this vector equation, cosine t plus sine t minus t, of course we should automatically recognize this. This is our spiral, or our helix, right here. And we're asked to find the binormal vector equation. So we need the tangent, and we need the unit normal. So the unit tangent vector, that is just going to be r prime over the magnitude of r prime, which is, that's not too hard to do. This is, let's see if we can just negative sine t plus cosine t, comma, not plus, sorry, cosine t, comma, negative 1. The magnitude, well, that shouldn't be too hard to get. This is going to become the square root of sine squared of t plus cosine squared of t plus 1. And that gives us negative sine t cosine t negative 1 over the square root of 2. Now notice, this is when I'm looking for the binormal, I'm going to pay attention. This is going to be a constant. We are happy about that. Let's put a smiley face. We're happy about that. So this means we can use the shortcut. That's going to be nice for us. Okay, so the next thing we need is we need the unit tangent vector, n of t. So that's going to be r double prime over the magnitude of r double prime. Now, so when I take the derivative, remember this is just going to be the 1 over square root of 2. This becomes negative cosine of t, negative sine of t, 0. That's the derivative here. Now the 1/2 is a constant, 1 over root 2 is a constant, so I just factored it out. Over the magnitude, well, remember the magnitude is just going to be 1 over the square root of 2. Because this just becomes the square root of 1. Well, it's going to be, and I still have that 1 over root 2 there. So those are just going to cancel. And that's what's nice about when this is a constant, this will always cancel. If this is not a constant, the magnitudes won't cancel. And that's when we can't use the shortcut. So what we wind up with is negative cosine of t, negative sine of t, 0. So we're next going to use the shortcut in order to get the binomial vector. B of t would equal the cross product, we're going to use the shortcut, r prime cross r double prime over the magnitude of r prime cross r double prime. Which is, don't forget, get r double prime, so this is going to be I, j, k, and we've been doing these a lot, r prime, which is this negative sine t, cosine t, should have spread it out more, negative 1, I'll make this k over here, over, what's that, negative cosine of t, negative sine of t, 0. Now, notice, I didn't worry about my magnitude, my root 1 over root 2 there, because that's a constant. See that 1 over root 2? I can just kind of factor that out. So at the very end, I can just multiply by 1 over root 2. And when we simplify this, what we wind up with is negative sine t cosine of t, 1. All over the square root of 2. There's our magnitude. That's our magnitude right there. All right, so go to part 2. We'll take a look at a few more examples. See you soon.